live now. Okay, we're live. All right, so good morning again, everyone. And welcome to our monthly KNoWS query research progress update. So the goal is still the same as always. So in order to hide away complexities for reading and writing for application developers, we work on technologies for making it more efficient to achieve read-write abstractions over decentralized data environments on the web. For that, these people are doing research in this area. So the plan for today is to have 3 slides for each researcher. First slide is high-level goal of the researcher, then accomplishments of the previous month, and then targets for next month. So let's get started with the first researcher on the list, and that is Brian. Over to you.
So my current high-level goal is to use explicit data structure to optimize link traversal queries, which means adding some document to describe the data model that is of what is published online, and also using the RAI pattern that where the data is actually published to find some optimization that we can do. And we can go to the next slide. So this month I work on 3 things principal in the main. So I work on resubmitting my paper titled Traveling with the Map, Reducing the Search Space of Link Traversal Queries. So I want to resubmit it to ISWC. So what I did is that I work on a running example. I made the approach a bit more clear, and I've added some figure, which was the main criticism of the paper. I've also realized something that the reviewer didn't see, is that my problem is closer to query subsumption than query containment. So I've also reworked the explanation to take that into account. The second thing is that I'm working on is to facilitate the queries of network with heterogeneous vocabulary, so using simple rules. So this month I mainly work on doing some more unit testing, because the implementation, at least the sample implementation that I have currently work and could also be relatively easily extended. I've also worked on a method to know if the streaming store is closed, because with the current implementation, we cannot really know when it is closed, and I need that for my reasoning loop. So I've worked on some PR for that. The third thing that I've worked on is on using indexes of federated indexes to index federated queries and the result inside some sort of materialized view to improve the performance of those queries. Because, for instance, in the context of bioinformatics, sometimes they redo the same query, or they make queries that are more restrictive than other queries. For instance, they want to have, I don't know, all the genes into a database, and then they want to have specific genes, so you could reuse those results. So what I did this month is that I've re-implemented an approach that uses first order logic, or at least I'm working on this re-implementation to solve query containment. But this approach supposes that we are using that Sparkle is set semantic, but Sparkle is actually back semantic. So I need to rework, to modify this approach to take into consideration real Sparkle queries. And I also want to take into consideration federated queries, and the paper doesn't support that. And I think that federated queries have some influence into the semantic of Sparkle, because data source of knowledge base are set semantic, and I think with federated query they're going to be back semantic, which adds some complexity. And I've also worked on making a library to parse the cache and to do the main objective, which is to use this as a cache hit algorithm or cache hit mechanism. We can go to the next slide. So for this coming month, I want to get more reviews for my paper, and to make it better. I also want to continue the implementation of the solver, and I want to start the adaptation for backset semantic, because the solver is quite well advanced. at least hopefully. And I also want to continue to formalize my approach for federated queries. I also want to create some demo, some example of some of the concepts that are different in the context of back semantic or in the context of federated queries. And I want to continue also the unit testing of my approach to query over heterogeneous vocabularies. And that's it for me.
Any questions? Yes, Maarten.
I remember at one point you were looking at query containment between shapes and just Sparkle queries. Is that still the case, or are you now looking at containment between Sparkle and Sparkle queries?
I'm looking into containment to Sparkle and Sparkle queries. And also realized that I wasn't really doing query containment when I was working on that. I was doing query subsumption, which is really similar to query containment, but it's still not the same.
Wait, but you're also doing queries and shapes, right? That's for the traveling with the map paper.
Yeah, this is what I'm saying, is that it's actually not query containment, it's query subsumption, which is really similar.
Query subsumption is subcategory of containment?
Yeah, but it's still not the same problem. It has different complexity and it's not exactly the same.
Mm-hmm.
But yeah, it's some sort of type of containment, but they're not the same. And it's not really, there was a lot of assumption that I could take when we were working with shape that I cannot take when we are working with whole queries, because shape always has this similar structure and are quite quote-unquote simple queries. So I cannot really retake what has been done for that work. Does it answer the question?
So the traveling with a map paper, so the status is it just needs reviews at this stage?
Yeah, because I've had some reviews from 2 other people, so I'm waiting for you, Ruben Eschauzier, and maybe Julian to get reviews from, because they said that they wanted to review.
Mm-hmm.
So it's just, yeah, sometimes we read it and make some small modification, but it's mainly waiting for some more reviews.
No. Yeah, I should be able to make some time next week.
Okay, cool.
Okay. Unless there are any other questions for Brian, let's go to Jonni.
Okay, so my high-level goal is to investigate adaptive client-side techniques for portable query optimization solutions over distributed linked data sources. And in the next slide. So what I worked on was mainly implementation work. So in Communica, I finished the HTTP rate limiter that is now merged. And then I fixed some errors and then re-implemented URI filtering for link traversal for an experiment that I wanted to make. And then in relation to that, in the RDF dataset fragmenter, I also re-implemented some things that I had previously done, but that I lost the code for. So yeah, and then the idea was to use all of that for benchmarking hybrid query execution over solid pods and Sparkle endpoints. So assuming that the same dataset is available through the solid document-based interface and a Sparkle endpoint, you could use the Sparkle endpoint. And I also made an experimental benchmark runner setup for it using GitHub Actions. And that one turned out to actually be quite successful despite some doubts. And it makes parallelization of the different configurations really straightforward and easy. And then I run into an issue with the link filtering approach not working in the latest version of Communica, because when we basically did the same as a quick prototype thing last year for a federated querying workshop. It worked, but for some reason now it's just it chops out all the results, and it's because of the way the traversal of links is done in Communica. So I have to look into that, which I think is on the next slide, if I remember correctly. Yep. So basically fixing the issue with the hypermedia query source and link queue and link filtering combination, because currently there's a hypermedia actor that does the but the way the sources are assigned is a bit like it's not working with the filtering, because one filter affects too many sources, and then when it doesn't affect too many sources, then it affects too few sources. So in the end, it either works like it works too aggressively, or it doesn't work at all. And yeah, the primary goals are to fix that, and then fix a bug with a source assignment that I'm hopefully getting closer to fixing. That was discovered last week. And then also I need to make pull requests for all the new code, so it doesn't get lost again. And then I want to write a short demo paper about the hybrid thing when I get the benchmarks running. And then also look into a demo paper on the rate limiter, because rate limiting should be a thing that is taken into account in practice. And then I also want to update and extend the joint plan restart work with a journal paper as the end goal. And I'm hoping to get to all of those within the next month, because I'm slowly running out of time in my my PhD. So yeah, if anyone has any questions.
Any questions for Jonni?
How is the stability of using GitHub Actions as a benchmark? Have you tested them?
It's varied a bit, but not as much as I was expecting it to. So I was just looking at, I can't remember the exact numbers, but it wasn't like a double the performance or whatever at random. It seemed pretty consistent. But
Did you compare it? Yeah.
Yep. I mean, I have to run it a few more times and then get back to you with the numbers.
Yeah, because I would compare it to JBR, for example, see the standard deviation. That would be interesting.
Yeah, I could actually do that. Yeah, because
when you say GBR, you mean show wall, right?
Yeah, on the virtual wall,
okay,
or whatever. Yeah, just on virtual wall and GitHub Actions and see the difference.
Yeah, I think I really should do that. It shouldn't take that much effort, and I also have a setup that just does basic link traversal. So I should be able to take that one and then compare it, and then have some numbers to actually prove that it works before I run the actual benchmarks in there. Thank you for for pointing that out.
Maurice?
You had a question, Brian, or not?
Yes, I have a question. I was wondering, does the rate limiter change the query plan, or it's more about not overloading endpoints?
It's just about spacing out the requests, so it doesn't affect the query plan, and it doesn't. I mean, I think it shouldn't affect unless there's a case where the initial request gets rate limited, and then that one affects the weight of an operation. But I don't think it should happen. So I think it should just basically space out requests, and if a source is being really slow and it ends up in the wrong place in the query plan, then it will just slow down everything. But at least like the main goal is to avoid requests being dropped by the server because of too many. of those.
Okay. So it's because I think when you do the hybrid querying with Solid, do you have duplicate data as a resource, as file, and duplicate data inside of a Sparkle endpoint?
Yeah, yes, that's what the link filtering was supposed to fix, but then it, because of the implementation, it currently filters out everything. So.
Okay, because I was just wondering if you could, or if it makes sense that if it's too slow to do the link traversal instead of doing your Sparkle and using the Sparkle endpoint, or it just never really happened that it can be that slow where it's better to traverse instead of using the Sparkle endpoint?
It could be that way, but I haven't thought about it. As in, it's not what I wanted to measure, because I wanted to assume that this Sparkle endpoint is able to handle like all the requests that it gets sent without any issues.
Okay, so it's basically not linked to, they are two completely different projects.
Yes, they are completely different, because the rate limiter was for the real world benchmarking thing that was going on, and that was running into some rate limit issues. So it was meant to fix those.
Okay. Then I guess we can move to the next person, and that's Maarten.
Yes. So my high-level goal is to optimize decentralized querying using aggregators. These are architectural components that perform some transformational data beforehand, and then users or clients can just easily get these results. In my case, the transformations are queries, and to make sure that queries stay fresh or up to date, I use incremental processing to make sure that they are up to date, that query results are up to date. Last month, I worked on the incremental query engine in Communica. Version 2.2 has been released. Most notably, it includes order by now. So yeah, that's now in the main branch, and some bugs, mainly an optimization that existed in Communica, where a binding stream that contains a cardinality of 0 would be removed, and like the binding stream would be stopped. But in an incremental query engine, even though the cardinality is 0 when the query is started, in the future, this might change and actually might produce a result. So I can do this optimization. So I actually removed it from the query engine. Then second is the query decomposition paper. Is a paper from I mentioned this last month. This is a paper from a thesis student that did the thesis at our lab, and we formed it into a paper and submitted it to the semantics in data spaces. Last month I actually explained what it was, but it's just, in essence, I decomposed the query. The query is decomposed into subqueries, and these subqueries are then executed separately to make sure that a cache hit is more likely. That's the essence of the paper, at least. And then finally, I started working on the aggregator proof of concept. And mainly it's the UMA flow, so the user managed access flow. So making sure that the aggregator actually has policies and authorization. That's the whole UMA flow and the policies is some research that is being done in our lab from another team. And then my next targets will be working on the query aggregator journal. So the aggregator proof of concept that I've been working on, actually continue working on this and also build use cases to show this working. Then the Communica resource paper that has been accepted for ESWC, the camera ready version, is later this week. So yeah, I've been working on this, but yeah, actually finishing it and making sure that the camera ready version is ready. And then finally, I'll be going to the Solid Symposium at the end of this month, or next month. I mean, yeah, the end of next month, where I might be showing off the watch party demo that is actually in the Communica resource paper. yeah, it's a watch party that uses solid technologies and incremental in front end, I guess, to update the chat and so on. But yeah, that's it for me. Are there any questions?
Yeah, I had a question. So you worked on the UMAflow integration into the aggregator. So how is that going at the moment? Because last time we talked, there were some open questions still.
There are still open questions, but I think the questions are more for the people that are actually working on the UMAflow, and not really for me exactly, because the spec that they are putting together is pretty open. So yeah, they want to make sure that a lot of use cases are actually able to be done with this whole specification, not like Solid at the moment. But yeah, if you have a specific question, you can always ask it, or I don't know if you remember what the questions were.
Not really from my end. I remembered some questions from your end.
Well,
but
no.
I think last time we talked about the fact that, if I remember correctly, the query, like a full Sparkle query, would be sent to their library, and then it was checked if the query was supposed to be answerable, and then you could start query execution. While another approach could be that the query engine decomposes the query into separate triple patterns, for instance, and then each triple pattern is sent separately to the library, to the UMA library, so that's easier for the UMA library to check if subqueries are answerable.
Right, I remember. No, pretty sure I actually know the answer, and it's the same answer I had then. To make sure that these policies are actually manageable and actually doable, it's not done on triple level, and it's done on, I guess, shape level. But that's at least the implementation that they are working on. But yeah, the specification that they're putting together for the UMAflow, or for the policies or whatever, or for the authorization, isn't limited to like shapes, but to make it performance, they are limiting it to shapes in the implementation. I guess that's the answer. But I'll be doing something similar, following their implementation, because they work together, of course.
No. So I guess then the query engine could simply do shape-based query decomposition.
Yeah, indeed.
A bit similar to what Brian is probably going to do as a next step in the shape index work, so that if a shape pattern is recognized in the query plan could be reformed so that the full query, so that the full shape can be sent to a certain directory, for instance.
But what is a shape pattern in the query?
That's a subquery that corresponds to the shape.
Okay, that's it. Okay. I was wondering if it was some, because it will be like a triple pattern, basically. A star pattern, I mean.
No.
Okay, I see. Thank you.
Well, not necessarily. I guess it could also contain a filter.
Okay, but yeah, the main will still be your multiple star pattern connected together with segment of the filter expression. That okay.
Mm-hmm.
But I see what you are. I was just wondering if it was something else that I don't know. Thank you.
All right.
I have also a question. So you said that now Incremunica supports the order by operation. Does that mean that now everything is supported by Incremunica? And what happens if I use some operator that isn't supported by Incremunica?
So very close to complete Sparkle support, like select Sparkle. The two things that are not supported are complex filters that use filter non-exists clauses. So for example, filter non-exist and something else in a filter expression, that doesn't work at the moment. Or if filter non-exists, then this or whatever, that isn't supported. So complex filter non-exist clauses, which is, yeah, doesn't occur that often, I think. And repeating property paths. So the plus and the star of the property paths are not supported. That are the only things in Incremunica. And if you use them, then you get an error and the query engine shuts down and you won't get a result.
Thank you.
Okay, let's move on. If my screen is, yes, there we are. It's over to you.
So my high-level goal is to optimize write performance in decentralized personal data ecosystems. So yeah, and currently I am looking at actually a interface data description. But yeah, next. So what I worked on is finishing the storage guiding framework and the storage guidance vocabulary, which is used by the storage guiding framework, demo paper for ESWS. And I made a video for that was uploaded.
What is ESWS? Do you mean ESWC or
Yes.
ISWS?
ESWC, yes,
Yeah.
ESWC. Oops. And I uploaded a video on the KNoWS channel for that demo. Yes, then I am demystifying the interface data description. So I'm trying to make a description that says if you have a certain HTTP resource, for example, how it can be constructed from the writes, and this how is then used. Like I use currently Sparkle algebra to express that relation, and then the idea would be that you can focus on some kind of resource with your query engine, and since the algebra is known, it can discover the relationships between separate HTTP resources. Okay, then I assisted with the knowledge graph course, which is a course being taught in the university. It was only one practicum, but apparently it took a lot of time, so I put it there. And I applied to ISWS, which is hopefully the correct name this time. Yes, and then I also got accepted for my Solid Symposium paper. No, for my PhD symposium. My God, it's not going well. Paper got accepted. So I will work on that next month. And I implemented round tripping in Dracula and made a logo. This is the logo. And the round tripping, I'm still working on it. But currently it works for parts of it, and I just need to debug the other parts. That's it for this.
I like your font.
Oh, thank you. Yes, it was a whole discussion.
All right.
So my next targets are releasing version 1 of Dracula, but that's not necessary for this month. Preparing the logistics research day, the logistics for the research day at the Technical University of Vienna, which I also said last month, but I didn't do yet. But I should start doing that. Then reading up on Sparkle non-materialized construct. So where you just have like you define a view, and I want to look at recursion, how that would work, optimizations, so that if you have, for example, a chain of views, that you can optimize it into a single view and like just rewrite your query on top of the materialized data. And then also looking at edits on views, which will likely be the hardest part because I read somewhere that it cannot be done 100% correct. So yeah, maybe it can, maybe it cannot. But I need to read these papers, and then I want to create an experimental server and client for the interface data description. So the description that I mentioned earlier, I want to implement an experimental setup for that to see how powerful it is. And yesterday I also talked with Professor Verborg, and he told me that I need to also write down good use cases and like clear use cases. And he gave me some already, but now I need to make them really clear. And that's it.
Any questions for Pete?
Yes. What is the round tripping?
Yes, so if you have a Sparkle query, it's just a string. And so if you're parsing it, you are making like some data structure that represents the string. And then you can say like, okay, now I have this data structure that represents the algebra. Yeah, the algebra and what actually makes sense for the functionality, right? But if you go from algebra, you can then go back to the string. But if you do that, it will not be the same string because, for example, things like spaces and comments don't matter within the algebra. And round tripping will allow you to actually track spaces and new lines and comments and stuff as part of the data structure that you generate from your parser. And then if you generate again, so if you go back to the string, you can go back to the same string. And then that allows you to, for example, make partial changes. If you have a certain node of interest, for example, I have a built-in function and I want to uppercase all built-in functions, you can simply visit the built-in function nodes in your algebra, look at their string notation and uppercase that, and then you can, yeah, it's nice for tooling.
Okay, but I'm not sure I fully understand is that because basically you have it as a string and then you create some sort of abstract syntax tree, I guess.
Mm-hmm.
But you want to take into consideration if you add comment or too much space because I guess in Sparkle it's the same thing to have 1 space or 5 space between stuff. But why is it important to go back to this string?
To go back to the string itself is important for example, Comunica uses it right now, uses the generator in Sparkle JS, but it's not the same string, and it uses that to send queries to Sparkle endpoints. And it's nice to have the same string if you're making tools like linters or refactoring things, for example, where you say like, oh, yeah, you have like this renaming stuff in your editor, then all of that functionality is really nice to have round tripping because you can edit the syntax tree.
Oh, okay, I get it.
But then get the same result.
Okay. So okay, I see. Thank you.
Yeah.
Yeah, and actually another use case I just realized for which the round tripping is important, or at least the consideration of comments is I'm not sure if there are any, but it's possible in theory that some query engines will support query hints using comments. And then it's important that we can forward those comments properly throughout the whole pipeline to the proper query engines.
Yeah, but there it might be more useful to use the modularity of Dracula, where you can actually also insert new
with the transformers, you mean?
No, not necessarily, but it's really easy to take the Sparkle base parser and start editing rules such that if you, for example, want hints or some kind of groups that do certain things, then you can introduce a new group. Like you have now the union or the optional group. You could make a new group, and then it would be part of your algebra, or it would be more than just a query hint because it would be actual part of the language, which would just be a way of doing things.
That would be better indeed, but
Yeah.
If a query engine currently would only support comments, then
Yeah.
that's
Also, but currently the hard thing with Dracula is the fact that it's both modular and the round tripping. It makes it, I think, hard to introduce things like classes, because that kind of takes away for the modularity if you start introducing a lot of classes. So that's kind of a balance that I need to find, and that's a meeting that I need to have with my supervisor. Ooh.
Yeah, just a small question there. Maybe I'm a bit confused, but there you mentioned Sparkle non-materialized construct, but then you mentioned edit on views, but these are materialized views then, I would guess. So are you looking into materialized views or not?
Yeah. Both, I guess.
Or will they be fully virtual? Or doesn't it?
I think it's most important to look at them as being virtual, and then if you want to materialize a view, it's with Maarten's work, it's as easy as slapping incremental on there, and you get a materialized view. So in that sense, I can mostly focus on materialized views, I think, and then delegate other problems maybe to the incremental engine. But in my description, you will often have these virtual views in the middle that aren't exported to some HTTP resource, and then you need virtual optimizations. You need optimizations on virtual views.
Yeah,
but it's a work in progress.
Well, okay. Then we can go to Ruben.
Okay, so I'm working on client-side query optimization for link traversal, which basically means we are wanting to use patterns that clients probably exhibit on the query sort of executions they do, and use that to guide query optimization as sort of prior knowledge. What I worked on is I had to rework the paper on link prioritization during link traversal, because I submitted it as a resource, but the reviewers thought it was more of research. So that's fine. I guess I'll just reposition it. And I also got some comments on the metric formulation, which were very correct. So I worked on improving the mathematical definition and sort of fixing some mistakes. And finally, for it to be a research paper, I want to do some additional stuff on the solid type index, because that's a really easy one to investigate in our current sort of environment. So I'll be doing some work on an oracle that takes the type index into account, because they use an oracle, and also a prioritization algorithm that just says, hey, any type index found links, we prioritize immediately, so we find that earlier, even if the link queue is entirely full.
And do you always prioritize if you find them, or only if they match the query?
Only if they match.
Okay.
All the links that are put into the link queue, actually, like the actual that have as parents the type index.
Yeah.
It's current implementation. To do so, I had to fix the type index in link traversal, because it was sort of outdated. So that is done and merged and should be working. And then other work I'm doing is the sampling over cached documents. And I finished the implementation, but there's a few issues. One of them is somewhat glaring. I don't have the results now, but I sort of have looked at it. Is that by the joint sampling cannot use the bind join yet. It only uses binary joins. And this makes it somewhat inefficient for at least some queries, because the bind join is very sort of optimal there. And also it uses more memory. So some queries actually get out of memory when it should work in default Communica. So that is one thing to fix. But then when you look at comparing default Communica with binary joins and the sampling is a lot better, because most queries don't even finish on larger what-diff datasets. So there's potential in the sort of join plan making. And also I saw some issues with the sampling efficiency. I was doing some useless calls to the count function of the store that we sample over, and I removed those, so we have better sampling efficiency there. I haven't validated it yet, but I strictly removed stuff and just reused data, so it probably is a little faster at least. So my next targets will be finishing the rewriting of the paper. I have to rerun the benchmark with all these type index prioritization stuff. And also I can, there's raw timestamps available now, I can more easily do the standard deviation. So I'll probably include that in my tables as well. Then I want to investigate how I'm going to include the bind join and other standard existing join optimization in Communica. So yeah, as I said, the benchmarks show that some queries will never be faster. So I need to include this, but the problem is, how do I align the cost estimation for sampling and other stuff in Communica with the existing cost estimation? Because it needs to be on the same scale and sort of makes sense. So that will be an interesting one to figure out. And finally, the proper benchmarking of caching is somewhat difficult because I hypothesize that there are patterns, but how do I model these patterns in my benchmarks? From the one hand, you can say, okay, I'll just do a normal benchmark with the repetitions, but that's like super good for caching because you have the same queries. And the other side of the spectrum, you can just do random query selection, but that is a lot worse because I don't expect it to also be random in the real world. So I need to find something in between probably and motivate that properly to reviewers. So that will be my month, I guess.
And do you have any concrete ideas yet on this random query selection?
I might investigate some real world use cases of apps or whatever, or computers, see how similar some of the queries are to repetitions, and model this statistically, and then have a sort of generating process that follows this real world selection thing. But it's difficult to really do.
You could probably write a whole research paper about that topic.
Yeah, that might be interesting.
Yeah,
It might be a good resource.
Yeah.
And then use it. But yeah, maybe the first one will just be, yeah, just having random queries or repeating queries and seeing the difference, then telling them, okay, yeah, this is the spectrum.
If you make them fully random, just make sure that they are random with a seed so that you can still reproduce that in.
Yeah, for sure.
Okay, cool. Any other questions for them? Okay, then I guess we are.
I have a question.
Yes.
I'm not sure I really understand what you mean by some query will never be faster without bind join. How do you know that?
Well,
Maybe I just don't understand.
I think because the bind join is so efficient in these queries that they reduce the sort of number of intermediate results so much that a binary join can never really catch up because it materializes way less intermediate results, and it's always going to be a lot faster. It seems to be that way at least. And maybe there are some algorithms out there, but the current algorithms in Communica, you need the bind join from some queries. Even with the perfect join plan, it will probably not be faster.
Okay, I think I sort of see what you mean.
Yeah, and since engines like BlazeGraph and so on also use bind join quite intensively, I guess that makes sense.
Yeah.
Okay, no other questions? All right, so the next time we see each other is April 29, again at 9:30. All right, thanks all for joining. See you next time. Bye.
Bye.
Where is the leave button?